And there's other things. Why can the modulated signal pass the filter? Yeah, this is what we did earlier. This is all the math, and then all the detail just repeat myself. Okay, so that's it about that, that exercise. Okay, so how does the filter remove or maintain a certain signals? We said there are 3 types of filters. There's a low pass filter, there's a high pass filter, and there's a band pass filter. So we can do one exercise and see how these filters are applied to our signals. For example, I have 3 signals to start with. I have G of 0, and G1, and G2. Okay, just by observing these 3 waveforms, you can immediately figure out the period of these 3 waveforms. So they are all sinusoidal wave equations. The first one has a period of 2 pi. Basically, the sinusoidal repeat for 1 time. That's your period, right? Then that's 2 pi is your period. What about the period of the second equation? Anyone want to speak up for the second equation? What is the period of the second equation? Basically,
is it pi?
Yes, it's a pi, right? It's how your waveform repeat for 1 complete cycle. And this one repeat twice, so the twice of the period is 2 pi, so a period is pi. How about the third one? What is the period of the third one? It's somewhere in between. So an easier way to think about it is 2 pi divided by 3. So when you repeat 3 times of your waveform, it reached 2 pi. That means it's a third of that. So 2 pi divided by 3 is the period of this function. So when you know the period, you can easily know the frequency, which is the inverse of your period. So basically just 1 divided by t, you know the frequency of these signals. So let's say now I know the frequency of these 3 signals. Which one has the highest frequency? The one has the smallest period has the highest frequency, right? Because the frequency is 1 divided by t. So the third one has the highest frequency, and the first one has the lowest frequency. Now let's see, I want to apply a low pass filter. And intuitively, you will think the lowest frequency will go through, right? And then because then this is first frequency, second frequency, and the third frequency. And my low pass filter does it is I keep the first frequency to be 1, means I didn't do anything to the first low frequency signal. For the second frequency, I will reduce their amplitude to a half. The third one, because the highest frequency, I will reduce their amplitude to a quarter of that. So once you apply to this low pass filter, your first low frequency signal is intact. And your higher frequency signal gets more and more diminished. Okay, the similar concept applied. So now let's do a band pass filter. I will let go for the middle frequency to be preserved. I'm not changing the middle frequency. That means the second one will contain or maintain the same shape, but the high and the low frequency signals are both going to be diminished, or their signal going to be reduced dramatically. The third one is a high pass filter. So again, if you corresponding, the x-axis is frequency. Your low frequency is on the left and high frequency on the right, and you will see the high frequency won't be changed. So your high frequency signal is preserved, but your lowest frequency signal is going to be reduced the most. Right? This is how you can apply the high pass or low pass filter, so you can intentionally reduce or keep a certain signal.